Hello, thanks for joining this video. So in this video, I am going to discuss or I'm going to show you how to convert a fraction to recurring decimal. So basically how to, when you are given a fraction, how do you convert it to a reoccurring or repeating decimal? That's the topic of the video. Now, since this is a video which is a part of the 8th grade math lecture series, obviously, one is expected to know how to divide two numbers, right? So this video is not going to discuss or teach you the basics of division. But when given a fraction, right, which can only lead to a decimal final result, how do you go about doing that? So let's just get right into it, right? Let's just take a number first. I'll take fairly small number. Let's say 19 over 27. Now this number, as you know, the top number 19 is the numerator. It is also known as the dividend, right? And the bottom number is called the denominator, as you know, and it is also called the divisor. Now, so that's just a quick refresher in case you have forgotten. Let me erase this so that I can make some space for the rest of the division. And yeah, let's just get right into it. So as you know, as I'm sure you're familiar with it, the way you divide any two numbers, you write the dividend inside a structure like this. Actually, let me move it down a little bit, right? You write the dividend inside a structure like this, and outside you write the divisor 27. Now right off the bat, you know that 27 doesn't go into 19. So what do? You put a decimal point and immediately you give yourself a 0 so as to make the dividend bigger, right? So now the dividend is not 19, it's 190. And how did it become 190? Because as part of the common technique to divide such numbers, whenever the dividend is smaller than the divisor, you put a decimal point and you basically give yourself a 0 right next to this to make the dividend bigger. So now what you're dividing into is 190. So how many times does 27 go into 190? Right now, depending upon your comfort level with numbers, right, you can easily say that this will be probably somewhere, let's say around 8, I would say, right? So let's just do it. So 27 times 8. This is 6, 5. Well, actually, this is a bit bigger. This is bigger than 190. So it's definitely 27 times 7, right? So this will be 49. 4 goes on top, 189. So the number that you multiply 27 with to get a result which is less than 190 is 7. So you put 7 here, right? And you put 189. You subtract as per the regular usual division technique. The answer is 1. Now obviously 27 does not go into 1, so what do? You give yourself a 0, right? You can do that because you are already in the decimal portion, right? You started with the decimal, and so as you may know, in this very common division technique that I'm seeing, whenever you get an answer after the subtraction, if that answer is smaller than the divisor, you can give yourself a 0, just 1 0 first. Now, and you have to try to divide the divisor into the result, which is 10. Now, does 27 go into 10? Obviously not. Or you can say 27 goes into 10 0 times. So you put a 0 here. 27 times 0 is 0, right? And you subtract, you get a 10, right? Now, again, you ask yourself the question, let me just write the 0 properly here so that it doesn't confuse you. So the answer here is obviously 10, right? Now, 27 does not go into 10. What do? You give yourself what I call as a free 0, right? You can do that because you're already in the decimal portion as far as the quotient is concerned, right? And now you see that you are dealing with 100, right? So you have to now try to find how many times does 27 go into 100, right? Which is what? Is it 4 times? Well, possibly yes. Yep, possibly 27 times 4 will give you roughly what? If you want to do it here, is 27 times 4 will give you 80. Let's see here. I'm going to erase this. 27 times 4, that is 28, 2, that is 10. So 108, that is bigger, 27 times 4 overshoots 100. So you can't use 27 times 4. So it has to be 27 times 3, which gives you, what does it give you? Is 1, 2, is 81, right? So you know that the number that you multiply 27 with to get a number which is less than 100 is 3. So you put a 3 here, right? And you put an 81 here. And what is the result when you subtract? It's 19. Now, obviously, 19 is too smaller than 27. So what do? Because you're in the decimal portion, already in the decimal portion of the quotient, you can give yourself a 0, just 1 0, and then again try to see if 27 goes into 190. Well, it does. And we already know 27 goes into 190 7 times because we already did it here. You notice this? We already did it here. So we can put a 7 here, put a 189 here, and you get 1. Now, as you hopefully are seeing, right, you got a 1 here. That's exactly what you got here. So you do the same thing, right? You know that 27 doesn't go into 1. So what do? You give yourself one free 0, as I keep saying, right? This is just my way of remembering it. Free 0 meaning you can give yourself a 0 out of thin air, basically, right? And now try to see if 27 goes into 10. Well, it does not. Or in other words, 27 goes into 10s 0 times. So 27 times 0 is 0. You subtract, you get a 10, right? Now, again, does 27 go into 10? It does not, right? So you give yourself another 0 to make this number bigger. And now you see that 27 does go into 100. How many times? 3 times. Again, you see this, we know this. From here on, from this point onward, right, it started repeating. You got a 189 just like you got here. You got a 10 just like you got here. And you got a 100 just like you got here, right? So you know 27, how many times is 27 going to 100? Well, 3 times. So what do you get when you multiply 27 by 3? You get 81, and you get 19 as the answer when you subtract, which brings us back to the original pattern. So hopefully now you can see that this pattern will go on repeating. 703, 703, and if you keep going with the division, you'll keep getting 703. Let me erase this here. You'll keep getting 703, right? So the point is that you are going to have a repeating pattern of 703, 703. You keep going. And obviously when you see that, you know that you cannot just keep on dividing, all the way till evening, right? You got to stop because you already know this pattern will repeat. And so this is a really good example that shows a repeating decimal. So how do you write this answer? You can't keep writing 703, 703 all the way, million times, right? So the way to write this is you basically say, the digits that repeat, you put a dash over it, right? So you can say, let me just write this here, 19 over 27 equals to 0.703, and you put a dash on top of the numbers that repeat. Which numbers are repeating? 703 is repeating, right? So you put a dash. So actually, you know what? Let me write it here so that it's clearer. The way you would write this division is, let me write it here, 19 over 27 equals 0.703. Now instead of writing 703 all the way here, you just put a dash on top. This dash indicates that these 3 digits are going to keep repeating. Okay. All right, so that's the first example. Hopefully you are getting warmed up. Let's do a few more examples, right? So let's go down here. And let's do, I guess we could do example, I don't know, let's say 27 over 32. Let's get right into it, right? You write 27 here and 32 here. Now, obviously, you know that 27 is smaller than 32. So 32 will not go into 37 unless you find a way to make this 27 number bigger. Well, how do you do that? Put a decimal point and give yourself a 0. So now you know that you're dealing with 270. Does 32 go into 270? Yes, it does. Well, how many times, right? So let's try, I don't know, if you try, 7 times, right? 7 times 32 will give you roughly 224, right? So you can probably go higher than 7. So 32, let's try 32 times 8. That gives you 16. And here 1, 25, 256. Okay. Now if I go 32 times 9, it'll overpass 270, right? It'll overpass 270. So 32 times 8. So 8 is the number that you multiply 32 with to get a number which is less than 270. So you put an 8 here, right? And you put what's the answer? You get 256. And just quickly check the math here just to make sure the number is correct. Yes, it's 240. I do it in a slightly different way, but yeah, you can do multiplication using whatever way you learned. Since this video is about decoding decimals, I'm obviously not going to get into teaching you basic multiplication, so hopefully you already know that. So double checking the answer here. Yes, answer is correct. So what do you do when you subtract? What do you get? You get a 14. Okay. Now, again, continuing with the division, does 32 go into 14? No. So what do you do? You can give yourself a free zero like this to make this number bigger. And now you know, and you have a number in which 32 can definitely go into a few times. So how many times does 32 go into 140, right? Does it go into, I don't know, 4 times? 32 times 4 will give you 136, I think, right? Let's check it out. 32 times 4 will give you, not 136, it'll give you 8 here and 128, 128. And yeah, that works, because if you do 32 times 5, you're going to definitely go past 140. 32 times 5 will give you, I think 160, right? So that's, well, it's higher than 140. So the number that you use to multiply 32 with is 4. And you get 128, right? So what's the answer is 12. Now, does 32 go into 12? Obviously not. So what do you need to do? You need to make this number bigger. And how do you do that? Well, you go give yourself a free zero. Well, how can you give yourself a free zero, you ask? Because this is a standard division technique, right? When you have a decimal point here as in the quotient already, and you get an answer after subtraction, you can give yourself one free zero to increase this number, right? You can't give multiple free zeros, right? So if this number was still lower than 32, smaller than 32, you would have to actually put a zero here, and as I did in the previous example, but we don't need to do that here because 120 definitely can accommodate 32. Well, how many times, right? It can't be 4 times, because we already know that 32 times 4 is 128. That is more than 120. So it has to be 32 times 3. So we put 3 here. And how much is 32 times 3? 32 times 3, you can multiply really quickly, is basically 68, right? I'm sorry, 66. So, excuse me, I made a mistake. It's 96. 32 times 3 is 96, which is basically what we need, right? So is 96 here. So you put 3 here, which I already did. I'm going to put 96 down here. And what's the answer? Answer is 24, right? Now, once again, you continue with the division, right? Because, see, many 8th grade tests will ask you to stop at 3 digits after the decimal point. If that's the case, you can stop right now. You can say the answer is 0.843. But just since we are practicing, I want you to know that you could potentially keep going and find another couple of digits, right? So let's do that. So now 24 is less than 32. So 32 does not go into 24 as it is. So you have to find a way to make 24 bigger. How do you do that? You give yourself a free zero. Again, you can do that because you already are in the decimal portion of the quotient. You can give yourself one free zero to increase this number, and it has become now 240. So how many times does 32 go into 240? Well, you already know 32 goes 8 times in and comes up with 256. So if you can probably guess that 32 times 7 will be less than 240, right? And that is the case here, right? Is 22, 224. So it's 224. Put it up here, subtract here, and what do you get? You get 16, right? And of course, sorry, I have to put 7 here, like so, right? Now you could, at this point, most schools will probably not ask you to go any further. So you could stop right here, and now you have the answer. So what is 27 divided by 32 is equal to 0.8437. Okay. Now, if your school wants you to go higher, if your school wants you to go add a couple more digits, you could keep going. You could come here. You could give yourself another free zero, like so, and you could see that 32 times actually 5. You know what? 32 times 5 actually does give you exactly 160. So I'm glad I spotted that, because this brings you to a full stop, a conclusion to the division. So basically 27 divided by 32 is, let me actually double check the math here. 32 times 5 gives you 0, 1, 5, 15, 60, 160. Yep, perfect. So actually this is better. So I was being a bit premature when I stopped here, when I didn't go through with this, right? But now you know that 27 divided by 32 leads to a non-recurring, a definitive answer, which is 0.84375. So let me write that here more clearly. 27 27 divided by 32 equal to, please bear with, my pen is not drawing properly. 32, there you go, is 0.84375. Now if you wanted to round it to 3 digits, you could do that. Since this video is not about rounding, I'll let you figure that out on your own. I may put a video on rounding if needed in this lecture series. So this is the answer for 27 divided by 32. All right. So how about we do a couple of more examples, right? So let me clear the space here. Let's see, what do we do now? Let's see, how about we do something like 41 over 90. Okay, so 41 over 90. This is what, and you want to see, you want to go ahead and divide this. So you, using the usual method, right, you put this like so, put 90 outside. Now right off the bat, you know 90 is bigger than 41, so it can't go into 41 unless you find a way to make 41 bigger. How do you do that? You have to give yourself a 0, and you can't do that unless you put a decimal point. So put a decimal point, give yourself a 0. Now how many times does 90 go into 410? Well, you know that 9 4s are 36, so 360. So 4 is a safe bet, right? You can do that on your own. You can say 90 times 4 gives you 360, right? The 360. And this is an easy number, so you don't have to do a whole bunch of multiplication. Hopefully you can see that right away, right? Like this. So this is, result is 50. Now 50 is obviously smaller than 90, so 90 does not go into 50. So what do? You have to find a way. Actually, let me write 50 in a better way so you can see it clearly. So answer here is 50. Okay, now obviously 90 is bigger than 50. You won't go into 50 as it is, so you have to find a way to make 50 bigger. How do you do that? You can give yourself one free 0. Again, my free 0 is again my notation, my way to make it sound easy. Just to let you know that you can only give yourself 1 0 to make this number bigger. You can't keep adding zeros if this number was still smaller than 90, right? But luckily for us, when you add a 0, it becomes bigger than 90. Now, how many times does 90 go into 500? It goes, well, you know that 90 times 5 will give you 450, right? And 90 times 6 will give you 540. So you can't do 90 times 6 because it'll overpass 500. So 90 times 5 is 450, right? And again, this is fairly easy. You should be able to figure that out, right? You can do some trial and error if you're doing this on your own. Because I'm a little more familiar with numbers, I can sort of see sometimes which number will be the right number to multiply. But if you don't know this, you can try it out. So you could actually actually solve this. You can say 90 times 5 like this, 0, 9 5 are 45, 450. So you could take your time to basically know this. So we put 450 here, we put a 5 here already, we put a 450 here, so answer will be 50. Now look here, we got a 50 just like we got a 50 here. Now obviously 50 is smaller than 90, so 90 won't go into 50 as it is, right? So what do? You have to find a way to make 50 bigger. How do you do that? You can give yourself one free 0, just one, right? You can't again keep adding zeros if this number was still smaller than 90. One free 0, you get 500. So already know from the previous step that how many times does 90 go into 500? Well, 5 times, right? So give yourself 5 on top. 90 times 5 is 450, right? You do this, and what's the answer? Guess what? Is 50 again. Now at this point, you should be able to clearly see that this number 5 is going to keep repeating. It's going to keep repeating as you keep doing that. So clearly, when you spot this, you don't need to keep going, right? You know that this is another example of a recurring answer. a recurring decimal answer. So at this point you can stop and you can simply say that 41 times 90 equals to 0.45555, or you can say this is equal to, I told you the methodology to indicate recurring numbers is 0.4, and which digit is recurring? Only the 5, right? So you put the 5 and you put a dash only on top of 5 to indicate that, hey, 5 keeps on going and going and going, right? So that is the answer of 41 over 90 is 0.45 recurring. All right. All right, guys, so this hopefully is helping you. Let's do one final example. In this case, let's take a slightly bigger number, right? I don't want you to think that I'm just, doing the, two-digit numbers, although most of the time you should only get at the 8th grade level two-digit number. But let's see how you can do this even for a bigger number. So let's see you do, the bigger number is, say, 4. You know what? Let me, sorry, I'm going to do this. Let's choose the number something like, I don't know, 192 over 258. Previous number I was thinking of would have been too big. So yeah, 192 over 258. This is, again, as you can see, 3-digit numbers, but the pattern is the same. The numerator is smaller than the denominator, right? So again, let's just get right into it. You write the numerator like so, put the structure around it, write the denominator here, right? And you go off to the races. Now, right off the bat, you know that 258 is bigger than 192, so 258 will not go into 192, right? You know that. So what do? You have to find a way to make 192 bigger. And the only way you can make 192 bigger is you can add a 0. But you can only add a 0 if you give yourself a decimal point. So you give a decimal point, you add a 0. Now you know that the number is not 192, is 1920. Okay, so this is way bigger than 258. You know that 258 will definitely go into 1920. Now, how many times does 258 go into 1920? I don't know. How about try, let's see, 8 maybe, right? If you try 8, does 8 work, right? So if you try 258 times 8, what do you get? You get 4, you get 6 here, 6, 4 here. So this is 2064. So 8 doesn't work, because if you multiply 258 by 8, you get 2064, which is bigger than 1920. You need a number which is smaller than 1920 as part of the division, the method of any method of division that you use, right? So by doing this, we know that it's not 8. Well, then if it's not 8, you know that it has to be 7, right? Because it can't be 6, because 6 would be too small, right? And to test it out, you can just do quickly 258 times 7. What do you get? This is 6, this is 5, this is 0, this is 4, 18. You get 1806, and this is less than 1920. So you know that 258 goes 7 times into this. Okay, and what is the answer? Answer would be 114, right? 1920 minus 806 is 114. You can do that. I'm sure you will find the same answer, right? Let me erase this one to make a little more space here. Okay, so you got the first step, which is 258 times 7 gives you 1806. The answer is 114. Now, obviously, you can see 258 is bigger than 1114. So it will not go into 1114 until you find a way to make 1114 bigger. How do you do that? You can give yourself one free 0. And when you do that, you see that the number changes into 1140, which is definitely can accommodate 258. But the question is how many times? So let's take a guess. Well, 258 will definitely go at least 4 times, right? Because 250 times 4 is 1000, 8 times 4 is 32. So that's 1032. So is that correct? So 258 times 4 shall give you 1032. So that makes sense. So you put 4. And if in case you're wondering that why can't we do it in 5, well, I know from just basically having familiarity with numbers that 258 times 5 will overshoot past 1140. So I'm not going to use that, but if you want to verify that, you can, if you're doing this question, you can verify that by actually multiplying 258 by 5. So take the time to learn it. You don't have to, match someone else's speed. It comes with practice, right? So remember, the more you practice, the better you'll become at anything. So put a 4 here, and you get 1 0 3 2, right? And when you subtract, what do you get? You get an 8. No, you don't get an 8, sorry. This is, you get a 108, right? Because this is 1032, this is 1140, right? So you get a 1. You can do this, right? 10 minus 2 is 8, and then you get here, this is 0, and then this is 1, and this is 0. So 108 is what you get. Now, when you see 108, you right off the bat, you know that 258 will not go into 108 until you find a way to make 108 bigger. How do you do that? Well, you can give yourself one free zero because you're already in the decimal portion in the quotient, right? So you can give yourself one free zero, and voila, what do you see? You get 108 turns into 1080, and you know that 258 will go into 1080 definitely. And how many times? You already know this from here. 258 goes into, it'll go 4 times because 258 times 4 is 1032, which is less than 1080. So you put this 4 here, you get 1032. And what is the answer you get here? You get 48, I think. Yeah, 48 is the answer, right? So 48 is the answer. Now what do you do? Well, now again, same thing, right? 48 is way smaller than 258. 258 won't go into 48 until and unless you find a way to make 48 bigger. How do you do that? Give yourself one free zero, right? And now you see 448 turns into 480, which can definitely accommodate 258. But how many times? Can 258 goes into 48 twice? No. If you do 258 times 2, that'll give you 516. That'll be more than 480. So you can't use 258 times 2. So the number that you use to multiply 258 with is 1. That gives you 258. 258 basically goes only once into 480 without overpassing it. So what do you get here? You do this subtraction, 2. And you get you get 222. That's what you get. That's your result from the subtraction. Now 222 is less than 258, so 258 will not go into 222 until and unless you find a way to make 222 bigger. How do you do that? Give yourself just one free zero, and it becomes 2220, which can definitely accommodate 258. But the question is how many times? Well, you can do that. Let me just make some space here. You can do that by just doing, just trying some numbers. You know that 258 will go at least, I don't know, it went 7 times here. You notice here, take a hint from your previous steps, right? So don't try to reinvent and try to go find the number from scratch. Try to see if you already know what is the ballpark number, what is the approximate number that you can use here. You know that 258 times 7 is 1806, right? And that's what we used here. Now here the number is bigger, it's 2220, so we probably can do 258 times 9. So let's do that. 258 times 9 gives you what? 72. 2 here, 7. 5 plus 7 is 52. 5 here is 23. So this is 9. 9 is too much. What I meant was to do is multiply 258 times 8. So you do 258 times 8 here, and you will see that 258 times 8 is definitely less than 2220. And the reason I know it is the right number, because here I already know that 258 times 7 is 1806. But because 1806 is too far apart away from 2220, I could potentially go up one number. So I made 8, I chose 8, and you will see that 258 times 8 will be much closer to 2220. So this is 6. It'll be 6 and 4. This is 2064. So this is 2064. Use make sure I write it correctly here. Accidentally wrote a 5, so this is 4. You subtract it. What do you get? You get 6, and this is 7 is 5, 1, and that's it. 156 is the answer. Okay, so 156 is the answer when you subtract this. Now we can do, as I said previously, right? Most eighth grade problems will not ask you to go past 3 digits. We already went to 4 digits after the decimal point, but since we're already here, let's just do one more, right? So the last, we'll make this the last one because we know that this division is not going to conclude with a perfect ending, meaning the final answer will be zero, right? With a remainder of zero. So we know that this division will keep on going with digits, right? So, but since we're already here, it probably just for the sake of practice, we can just do one more step. Even though, as I said, in eighth grade, most of the questions will not expect you to go more than 3 or 4 digits after the decimal point in terms of division, in terms of finding the quotient, right? So 156, now you know that 258 does not go into 156, right? So unless you make 156 bigger, the way you do that, give yourself one free zero, make it 1560, which definitely is bigger than, can accommodate 258. But how many times? Does it go, I don't know, 5 times maybe? Yeah, let's try, we can even try 6 times, right? If you try 6 times, that will be too much actually. So let's try 5 times and see, does 258 times 5 come really close to 1560. This is this 4 9. So I'm just doing this is 35 plus, so this will be, I'm just going to erase this here. This is, so if you 40, this is 4, so you will get 9 here, and you get 2 to the 10, 12, 1290, right? So 1290 is, because is as close as you can get, I think, right? Because if you do 258 times 6, you'll probably overshoot it. Let's try that. Actually, 258 times 6 works way better. So I take that back. 258 times 5 is not the closest number. The result of 258 times 5 is not the closest number. It's 258 times 6. And I'm glad I checked myself. And that gives you 1548, right? You can do the math. 8 6 is 40, 8 times 6 48. 8 goes here, 4 goes here. This is 4 3 15. So 1548 is the right answer. So you do 1548, and the answer is 12. Now again, you see you can keep on going, but there isn't any need. You could potentially stop here, and the answer of this, which is basically 192 over 258, equals to 0.07441. Now you can keep going if you want to do that for your own sort of satisfaction, or if you are curious. But like I said, most eighth grade questions will be okay if you stopped with 3 or 4 digits after the decimal point. All right, guys, so that concludes this lecture on how to convert fractions to decimals. Some of them will be recurring decimals, some of them will not be, but the method is the same. And hopefully this video helped. Thanks for joining. And by the way, if you want me to make a video on any specific topic, please drop me a comment. Thanks. Bye.